Hello students. So in this video we will see problems on combination of cells, that is from current electricity only. So combination of cells. So these problems are very simple, just using formula you are required to substitute in it. So first problem if I take, which has appeared in 2015, there are two cells of EMF 2 volt and 4 volt, and their internal resistance is 1 ohm and 2 ohm respectively, are connected in parallel, so as to send current in same direction through an external resistance. So current should be in same direction through an external resistance of 10 ohms. You are required to find the potential difference. So first draw the circuit diagram. So there are two cells. Two cells are connected in parallel across an external resistance. So external resistance is of 10 ohms. External resistance is of 10 ohms. So 2 volt, 1 ohm. Second cell is of 4 volt, 2 ohms, and they are sending current through external resistance of 10 ohms. You are required to find potential difference across this. You are required to find V. So first, this cell value I will take it as E1 and R1. So E1 I will take it as 2 volt, R1 is equal to 1 ohm. This I will take it as E2 and R2. E2 is equal to 4 volt and R2 is equal to 2 ohm. So now first step, in combination of cells you are required to find effective EMF. You are required to find effective EMF, that is E is equal to, for two cells combination, effective EMF is given by E1 R2 plus E2 R1 divided by R1 plus R2. E1 R2 plus E2 R1 divided by R1 plus R2. Now substitute these values. So if I substitute, I will get 2 into 2 plus E2 R1, 4 into 1 divided by R1 plus R2, 1 plus 2. So you will simplify. So 2 into 2, 4, 4 plus 4, 8. So you will get 8 by 3. So 8 by 3 using calculator, if you divide 8 by 3 is 2.666 volt. 2.666 volt. This is E. Now in second step, find effective internal resistance. In second step, effective internal resistance, that is small r. Effective internal resistance, so small r, that is given by R1 R2 divided by R1 plus R2. So there are two cells, effective resistance. So if I substitute R1 R2, 1 into 2 divided by 1 plus 2, that is 2 by 3. 2 by 3 is 0.666 ohms. Internal resistance is 0.666 ohms. Third step, find main current, that is I. Current passing through this external resistance. So main current or total current you may say, main current I. So I is equal to E divided by R plus R. Now substitute. E is 2.666, capital R is 10 ohms, small r is 0.666. So 2.666 divided by 10 plus 0.666. So using a calculator, simplify, you will get main current. So using calculator, if I simplify this, so current I will get around approximately 0.25 ampere. I will get around 0.25 ampere or 0.24999 you will get current. So now you have found out current passing through this 10 ohm resistance. So you have found out the current. Now potential difference across this is given by Ohm's law, V is equal to I into R. So in fourth step, potential difference across 10 ohms. So potential difference across 10 ohms. So you will have V is equal to I into R. So I is how much? 0.25. External resistance is 10. External resistance is 10. So if you multiply, you will get 2.5 volt. This is answer. Clear, students? If you see, problem is very simple and is worth 5 marks. So for circuit diagram 1 marks, for each step you will be getting 1 marks each, so total you will get 5. So you can pause, solve this problem, then we will go for the next one. The second problem if we take, so directly he has given a diagram. He has asked us to find power across 10 ohm resistance. So in last problem we are required to find potential. Now instead of potential he has asked power. So again I will note down these values. I will take this as E1 R1. So E1 is equal to 3 volt, R1 is equal to 1 ohm. Second, 4 and 1, E2 is equal to 4 volt, R2 is equal to 1 ohm, R2 is equal to 1 ohm. So again same steps as we have solved. So first step, find effective EMF. Effective EMF. So formula is E is equal to E1 R2 plus E2 R1 divided by R1 plus R2. R1 plus R2. So if I substitute, so you will have E1 R2 3 into 1 plus E2 R1 4 into 1 divided by 1 plus 1. So that is 7 by 2. 7 by 2 is 3.5 volt. This is effective EMF. In second step, effective internal resistance. So just I will write it as effective small r, effective internal resistance. So formula is R is equal to R1 R2 divided by R1 plus R2. So substitute. R1 and R2 both values are 1. So you will have 1 into 1 divided by 1 plus 1. So that is 1 by 2, you will get 0.5 ohms. 0.5. So after finding E and R, our third step will be to find the main current or total current. So third step if I take main current or total current. Main current. So formula is I is equal to E by R plus R. So substitute. E is 3.5 divided by capital R is 10. Small r is 0.5. So again using a calculator simplify, 3.5 divided by 10.5. So 3.5 divided by 10.5, you will get 0.333 ampere. So using calculator if you simplify, you will get 0.333 ampere. And now final step. So instead of potential, he has asked us to find power. So power across 10 ohms. Power across 10 ohm resistor. So formula is P is equal to I square R. So we have found I. R he has given 10. Substitute, you will get power. So I is 0.333 square. Resistance is 10. So simplify this, you will get answer. So 0.333 square into 10 you will get 1.11 watt power across 10 ohm resistance. Clear, students? Again you can pause and solve this problem. So now if we take third problem, so it has appeared in March 2015. So he says two identical cells. So he says two cells are identical, means their EMF is same and even internal resistance is the same. Either in a series or parallel combination, whether those two cells you connect in series or connect those two cells in parallel, they will give same current of 0.5 ampere. So current they will give same, that is main current is same and external resistance is 4. You are required to find EMF and internal resistance. So I will take, let E is equal to EMF of each cell. I will take EMF of each cell as E, and R is equal to internal resistance of each cell. Internal resistance of each cell. So two cells are there, their EMF is E, each one is of E, each one is having internal resistance R. So whether they are connected in series or parallel. So first if I take, they are connected in series. So two cells are connected in series. So two cells are in series across an external resistance. Across an external resistance. So E, comma, internal resistance R. Internal resistance is R. This is main current I. External resistance is of 4 ohms. 4 ohms. So now, if cells are connected in a series, then effective EMF will be E1 plus E2 plus E3, so on. So here, first effective EMF, I will write it as E effective because I have taken here it as E, is equal to E1 plus E2. So both are equal, E plus E. Therefore, effective EMF is 2E. Clear, students? In parallel formula is E1 R2 plus E2 R1 by R1 plus R2. In series, directly you add, you will get 2E. Similarly, second, that is R effective I will take, internal resistance. So in series it is R1 plus R2. So again both are equal. So you will get 2R. 2R. In third step, I will write expression for main current. So main current if I take, I is equal to E effective. Instead of writing E, I will write it as E effective R plus R effective. R effective. So now if I substitute, so main current I, how much he has given? 0.5 ampere. So current is 0.5 ampere. So if I take 0.5 is equal to E effective is 2E. External resistance is 4. Internal resistance is 2R. So 0.5 is equal to 2E divided by 4 plus 2R. So this is our equation 1, or else I will cross multiply. So if I cross multiply, I will be writing here only. If I cross multiply this, 0.5 into 4 is 2 plus 2 into 0.5 is 1. 2 plus R is equal to 2E. So this I will take it as equation 1. So this equation 1. 2 plus R is equal to 2E. Now similarly, if both are connected in parallel, so if I take second parallel. So if both are connected in parallel, then E effective, else I will have a diagram for this. So circuit diagram if I take, so two cells are there connected in parallel. across external resistance of 4 ohms. So E, internal resistance R, E, R, this is 4 ohms and current is 0.5 ampere. 0.5 ampere. So for second parallel, if I find E effective, so if I take E effective is given by E1 R2 plus E2 R1 divided by R1 plus R2. So R1 plus R2. Now if I substitute E1 and E2 are E, small r is R. If I substitute E into R plus E into R divided by R plus R. So you will have 2ER. So I will take, you will have 2ER divided by 2R. So you will get E effective is equal to E. 2 gets cancelled, R gets cancelled. Now I will calculate effective internal resistance. So effective internal resistance. So for parallel formula is R1 R2 divided by R1 plus R2. So second, R effective is R1 R2 divided by R1 plus R2. So substitute, you will have R into R divided by 2R. So R gets cancelled, you will have R effective as R by 2. Then again similar to this third step, main current. So in parallel main current, I is equal to E by, or you can say E effective divided by R plus R effective. Now substitute, I is 0.5, E effective how much we have got in parallel? E. So E, capital R is how much? 4. So 4, small r effective is R by 2. Now this 2 will go to the numerator after taking LCM. ಇಲ್ಲಿ LCM ತಗೊಂಡ್ಮೇಲೆ ಇದು 2 ಮೇಲೆ numerator ಹೋಗ್ತದೆ. So you will have 0.5 is equal to 2E divided by 8 plus R. So 4 into 2 8, then 2 will go to the numerator. Cross multiply, so you will have 0.5 into 8 is 4 plus 0.5 R is equal to 2E. This is equation 2. Equation 2. Now you solve these two equations, you will get internal resistance and EMF. Now you simplify these two. So this equation also I will write over here, then I will simplify. So 2 plus R is equal to 2E. This is equation 1. So from 1 and 2 I will take now. So if I simplify, I will get small r and capital E. So you can try till then I clean the board. So you solve those equations, find R and E. Find R and E. So now from 1 and 2. From 1 and 2. RHS of both equations is same. So I can equate LHS. Else you can keep one below the other and solve. Simultaneous equation gatle solve madri. Illa RHS same ada. LHS equate martene. So I will get 2 plus R is equal to 4 plus 0.5 R. So I will take 0.5 to the LHS, 2 to the RHS. So R minus 0.5 R is equal to 4 minus 2. So 0.5 R is equal to 2. R is equal to 2 by 0.5. So you will get R is equal to 4 ohms. So internal resistance is equal to 4 ohms. This is first. Now substitute this value in 1 or 2, you will get the value of E. So I will take 1. So from 1, 2E is equal to 2 plus R is equal to 2 plus 4. 2E is equal to 6. Therefore E is equal to 3 volt. Clear, students? So here, just for CET, you can remember this hint. In combination of cells, identical cells, in combination of identical cells, if I in series is equal to I in parallel, then always capital R will be equal to small r. If you observe, you have got 4 ohms, capital R he has given. If you go back and observe, capital R is also 4. So cells ಒಳಗೆ identical cells ಇದ್ದು ಅಂದ್ರೆ ಅವು series ಒಳಗೆ ಜೋಡಿಸ್ರಿ ಅಥವಾ parallel ಒಳಗೆ ಜೋಡಿಸ್ರಿ, current same ಇತ್ತಂದ್ರೆ small r will be always equal to capital R. This is hint for CET. So you can solve this, then we go for the next problem. So fourth one, students, this has given in model question paper. So there are 6 lead acid type secondary cells, each of EMF 2 volt. Means all those 6 are identical, having internal resistance 0.015. They are joined in series. So he is joining it in series. To provide a supply to external resistance is 8.5. So find current and terminal potential difference. So you are required to find current I and voltage V. So again, if I take a diagram, there are 6 cells joined in series, 3, 4, 5, 6. 6 cells joined in series across an external resistance. So all these are identical. So current, so external resistance is 8.5 ohms. So all are identical. I will take it as E, and each internal resistance is R. So you are required to find current I and voltage V. So again, same 4 steps we will be having. So first one is E effective EMF. So if they are in a series, then we are adding. So all are identical. So directly I will take 6E, 6 into E is how much he has given? 2. So 6 into 2, that is equal to 12 volt. Clear, students? E plus E plus E plus, instead of adding 6 times, 6 into E I have taken. Second, internal resistance effective, R effective. Again, R1 plus R2 plus R3, instead of doing, I will take it as 6R. So 6 into 0.015. So use calculator and multiply. 15 6 90. So you will get 0.09 ohms. Once you confirm through calculator, 0.09. Third step, main current. So main current or total current, what he has asked. So main current I is equal to E effective divided by R plus R effective. Now substitute. E effective is 12. Capital R is 8.5. Small r is 0.09. So use calculator and simplify. You will get current I is equal to, so 12 divided by 8.59. So 12 divided by 8.59. So you will get 1. So using calculator, if you simplify, 1.396 ampere. This is main current I. Then fourth, terminal voltage. So again by Ohm's law. So fourth one, V is equal to I into R. So I is 1.396, capital R is 8.5. So using calculator again multiply. So if you multiply, you will get 11.87 volt. 11.87 volt. Clear, students? So on this combination of cells, problems are simple. So you can practice this. Again, few more problems we'll see in our next video.